Hello students, in this video we are going to discuss the chemistry important question answers for the coming NEET exam, and I am sure this is going to be very helpful for your revision and for your preparation. Let us start this video. So we have first question here. A clean metal surface irradiated with light of three different wavelengths, lambda 1, lambda 2 and lambda 3. The kinetic energies of ejected electrons are as follows. Lambda 1 2.9 into 10 raised to power minus 29 joules. Lambda 2 is approximately 0 and lambda 3 is 4.2 into 10 raised to power minus 19 joules. We know the relationship that energy is equal to Planck's constant h into c by lambda, which means energy is inversely proportional to wavelength. Energy is inversely proportional to wavelength means shorter the wavelength, higher the energy. Higher the energy, shorter the wavelength. So accordingly, when we go to arrange them in the increasing order of wavelength, then definitely lambda 2, which has a 0, has highest energy in the order of increasing wavelength, highest wavelength, then lambda 1 and then lambda 3. So option 4 is the right answer for this question. Second question, when electron transition takes place from n is equal to 4, n is equal to 4 means n is equal to 4 to n is equal to 2, which means n1 value is 2 and n2 value is 4 in hydrogen atom, then the number of spectral line. To find out the spectral line, we have a formula, that is n2 minus n1 into n2 minus n1 plus 1 divided by 2. When we substitute the values where n2 is equal to 4 and n1 is equal to 2, we will get the number of spectral lines equals to 3. The number of spectral lines are 3. We have one more question. If Kp for a reaction A plus 2B gives rise to 3C plus D. So for this reaction, Kp is 0.05 atmosphere at 1000 degree. We need to find out its Kc value for in terms of R. So we know the relationship between Kp and Kc. Kp is equal to Kc into RT raised to power delta N. For this particular reaction, delta N when you calculate by using Np minus Nr, so here number of moles of products are 3C and 1D, 4. And number of moles of reactant 1A and 2B, that is 3. So 4 minus 3 is equal to 1. So delta N value will be 1. So when you find out Kc by using this formula, Kc is equal to Kp divided by RT to the power of delta N. Kp is given 0.05. So temperature is given, that is 1000. When you substitute, you will get the answer 5 into 10 raised to power minus 5 divided by R. So option 4 is right answer for this question. 49th question. For a given reaction, this is the reaction, gaseous reaction. If 10 ml of iodine reacts completely with hydrogen, then find out the required volume of hydrogen. So in this given equation, we can see that one volume of hydrogen combines with one volume of iodine to produce 2 volume of hydrogen iodide. So if they provide 10 volume of iodine, then definitely we need 10 volume of hydrogen for this completion of this reaction. So answer is 10 ml. Let us move to the next question. So here next question is, which of the following is a correct increasing order of oxidation number of oxygen? So among the given option, in barium peroxide, oxidation number of oxygen is -2. In potassium superoxide, it is a superoxide, and we know in superoxide oxidation number will be -12. In ozone, as ozone is in the elementary state, oxidation number will be 0. In OF2, as fluorine is more electronegative than oxygen, so oxidation number will be +2. So by seeing this, we need to write them in the increasing order. So in the increasing order, option 2 is the right answer for this question. Let us move to the next question. pKa value for 3 acid A, B, C has been given. Which of the following represents the correct order of acidic strength? We know that acidic strength is inversely proportional to pKa. Means lesser the pKa value, higher the acidity. Higher the pKa value, lesser the acidity. So in that case, the most acidic is the one which is having less pKa value, that is 3.5, that is B. So right option is option 3. B is more acidic and C is less acidic because C has higher pKa value. Let us move to the next question. So here standard entropy of entropy means yes, x2, y2, x, y3 according to this equation are 60, 40 and 50 joules per Kelvin per mole respectively. If delta H is minus 30 kilojoules, to be at equilibrium, the temperature will be, we need to find out the temperature. So first, by using delta S, entropy value, we will find out delta S. So delta S we can find out by the formula delta S is equal to Sp minus Sr. So Sp means entropy of product. Product is xy3, 1 mole, and xy3 entropy value is given, that is 50. Substitute. Then Sr means entropy of reactant. There are two reactants here, half mole of x2. 1 mole of x2 value has been given, that is 60, half mole means 30, you substitute. Plus we have one more reactant, that is y2, 3 by 2 of y2. 1 mole of y2 value has been given, that is 40. So the 3 by 2 of y2, if we calculate for this 40, we will get 60. So 60 plus 30 minus 50, we will get minus 40 joules per Kelvin. So we got here delta S. So by using delta S, now we can find out the temperature by using the relation temperature T is equal to delta H by delta S. So enthalpy change has been given for this reaction, that is minus 30 kilojoules per mole, and delta S we have calculated, that is minus 40 kilojoules per mole. When we divide this delta H and delta S, we will get 750 Kelvin as a temperature. Let us go to the next question. Select the incorrect statement. We need to find out the incorrect statement. Let us go to the first one. An adiabatic system can exchange energy with its surrounding. Yes, it is a correct statement. Let us go to the second statement. A thermodynamic property which is intensive. So intensive means what? The property which are independent to the mass. And the property which are independent to the mass are not additive. That's why this second statement is incorrect for this case. Let us move to the next question. 54th question. Correct increasing order of metallic character. Now metallic character depends on the tendency to lose electron. So we know across the period metallic character decreases because size decreases, and down the group metallic character increases because atomic size increases. So accordingly, if you see the first option, that includes silicon, phosphorus and sulfur. So this is the not a correct increasing order, because silicon has more metallic character than phosphorus and silicon. Then in second option, this is also incorrect order, because arsenic has more metallic character because its size is bigger, they belongs to group 15. And option 3 also wrong order has been given, because among them aluminium has more metallic. Whereas option 4, if you can see, this is the right statement, because they all belongs to period 4, and in period 4, first arsenic will come in group 15, then selenium in group 16, then bromine in group 17. So accordingly, bromine has less metallic character and arsenic has more metallic character. So option 4 is right answer for this question. Let us move to the next question. This question belongs to periodic property. Identify the incorrect match. Let us find out the incorrect match. First one, unnil unnium. Unnil unnium is also official name is mendelevium. It is right. Second, unnil trium is also called as leverancium. This is also right one. Third one, unnil hexium is official name is seaborgium. It is also right one. Unnil unnium, that is 111, is called as rontigenium. Rontigenium, not dermastadium. So dermastadium is the name of 110 atomic number, unnillium. So this one is the incorrect match in this case, that is option 1. D with 4 is the incorrect match. Let us move to the next question. The electron affinity. We know in the whole periodic table, the highest electron affinity can be found in chlorine, not in fluorine. So accordingly, option 1 is the right answer for this question. 57th question. In which of the following molecule the most predominantly covalent molecule? So let us go to the next question. In the next question we have, in which of the following molecule the most predominantly covalent molecule? As you can see that sodium, lithium and magnesium are highly metallic in nature, so they definitely have ionic bond. Whereas if you see beryllium and chlorine, among beryllium and chlorine we can find electronegativity difference is very less compared to other metals with chlorine, where electronegativity difference is very high. Whereas between beryllium and chlorine, the electronegativity difference is less than 1.7. So beryllium chloride predominantly covalent in nature because their electronegativity difference is very less. Next question, which of the following compound does not show hydrolysis? So among the given 4 option carbon tetrachloride does not react with water, does not undergo hydrolysis, which means does not react with water, because first of all carbon tetrachloride is non-polar, and second reason, in carbon tetrachloride carbon does not have any vacant orbital to form a bond with water, whereas in remaining case in NCl3 NCl bond is weak, it can easily breakable. Mg3N2 SiH4 also can be react with water, but CCl4 does not react as it is non-polar. Let us move to the next question. In the next question, which of the following nitrate salts, lithium, sodium, iron, beryllium nitrate salt, does not give brown color gas? Brown color gas is nitrogen dioxide gas. So among the four options, sodium nitrate and including potassium nitrate also, sodium and potassium nitrate on decomposition, they does not give nitrogen dioxide brown color gas. Instead, they give NaNO2 and O2. So NaNO3 and KNO3 is the right answer. Let us move to the next question. In the next question, we need to find out the compounds with their correct structure. If you see carbon ClF3 is T-shape. PCl5 is trigonal bipyramidal. IF5 is square planar. Carbon tetrachloride is tetrahedral, and XeF4 is square planar. So option 2 is right answer for this question. This belongs to P block element chapter. Let us move to the next question. In the next question, it is related to ozonolysis. So when you do ozonolysis of olefins, we'll get two products, CHO, and this one, two aldehydes, two different aldehydes we are getting. One has 2 carbon, one has 4 carbon. So definitely, whatever the olefins you use for ozonolysis, the olefin must contain 6 carbon atoms. So in option 1 is cyclopenta 1,3 diene. Cyclopenta 1,3 diene. When you do ozonolysis, wherever there is a double bond, there it undergo breakdown. It undergo breakdown here. So to give 3 carbon aldehyde and 2 carbon aldehyde and 3 carbon aldehyde. So this one, you will get these 2 aldehydes. So these 2 aldehydes we are not having in our option. Second option is cyclohexane 1,4 diene. So when this undergo cleavage, exactly you will get 3 carbon aldehydes, 3 carbon diol, 3 carbon. But in the option 3 carbon diol is not there. One is 2 and one is 4. When you see the fourth option, buta 1,3 diene, when this undergo ozonolysis, it gives 2 carbon aldehydes, 2 carbon diol, ethane 1,2 diol. And when you see the third option is cyclohexa 1,3 diene. Cyclohexa 1,3 diene, when it undergo ozonolysis, it will get 2 carbon aldehyde and one is 4 carbon aldehyde. So this only we have in option. So option 3, cyclohexa 1,3 diene is the right answer for this question. Let us move to the next question, children. We have 3-chlorobutanoic acid. When it treats with soda lime, NaOH and CaO, there is a decarboxylation. This carboxyl group undergo decarboxylation to form sodium carbonate, and we will get 3-chloropropane. So this 3-chloropropane, when heated, there is a release of HCl, chlorine from second carbon and hydrogen from the first carbon. So there is a generation of double bond between first and second carbon to get propene. So option 3 is the right answer for this question. Now the next question is the correct order for the rate of decarboxylation. The correct order for the rate of decarboxylation of the following compounds with soda lime. Again, soda lime, it leads to decarboxylation. So decarboxylation occurs, the rate of decarboxylation, it is depending upon the stability of carb anion. So remember that the rate of decarboxylation is directly proportional to the stability of carb anion. The carb anion which is highly stable, that is having more rate of decarboxylation will be there. So among the given 4 options, we need to find out the rate of decarboxylation where you can find more decarboxylation. The more decarboxylation you will get in option 4. There you can find 2 nitro groups, one at ortho position, one at para position. So because of that, it will get the stable carb anion, in this case stable carb anion. Then second is option 1, where the nitro group is present at the ortho position. Then the next one is the compound where ortho position at the para position, and the least one is the nitro group present at the meta position. So option 1 is the right answer for this question. Next question. In the next question, children, select the compound having minimum boiling point, less boiling point among the four. So we know boiling point depends on the molecular weight, and as the number of carbon atom increases, there will be more boiling point. So among the four option 3 and option 4 having 5 carbon atoms, so they don't have the minimum boiling point. Option 1 and option 2 both having same number of carbon atoms, butane and isobutane. And one more concept we know, boiling point is inversely proportional to branching. As branching increases, boiling point decreases if the molecular weight is same. So in option 2 you can find branching, so option 2 having minimum boiling point. Let us move to the next question, children. We have one compound. The total number of substituent present in the above compound. We need to find out the total number of substituent. As we know, carboxylic group, according to IUPAC, carboxylic group is a functional group. It has more priority, whereas chlorine, bromine and iodine will be having less priority. So chlorine, bromine and iodine will be having substituent groups present in this compound. So these three are the substituent groups. Option 3 is the right answer. Next question, children, we need to find out which of the following is optically inactive. Optically inactive means they don't have the capacity to rotate the plane polarized light. And optical activity depends on the chirality. The carbon must have 4 different groups to be attached. Another one is plane of symmetry. So wherever you find chiral carbon, in whichever the compound we are finding chiral carbon, and wherever you are finding plane of symmetry, that will be plane of symmetry is not there, that is optically active. So wherever you are finding chiral carbon atom, that is optically active, and wherever you are not finding plane of symmetry, that is optically active. So among the given 4 options, as we can clearly see, in option 3 it does not have chiral carbon and it is having a plane of symmetry also. So option 3 is optically inactive. Let us go to the next question. Incorrect one from the given statement. So in the first statement, metamers is given. We know about metamers. You can find in ethers. So we have one ether where in the first compound, at one side you can find 3 carbon, at another side 1 carbon chain. So another ether where you can find across ether bond, 2 carbon chain at right side and 2 carbon chain at left side. Both are having same molecular formula, and whereas they differ in the number of carbon chain across ether bond. So they are the metamers. So this is the correct statement. In the second option, they have given geometric isomer. One is trans, one is cis. So they are the geometric isomer. This is also correct one. In the option 3, what we can find is acetyl acetone. So in this acetyl acetone, ene means double bond, all means alcoholic group. When the hydrogen atom shifts here and double bond shifts here, there is a generation of enol, double bond and OH group, and it is more stable than keto form compared to keto form. When there is a shift of this hydrogen to this oxygen and double bond between these 2 carbon atom, double bond here and H here, that is called as enol. This part is called as enol, and enol is more stable than keto form. This is also the correct one, whereas these 2 are the chain isomers. So this alcohol and this alcohol, they cannot be the chain isomer because the carbon position is different, so they cannot be a chain isomer. This is the incorrect statement. So next question we have from chemical kinetics. For the given reaction, they have given one reaction. Rate of appearance of C is 6 into 10 raised to power minus 2 mole per liter per second. The rate of A consumed, the rate of disappearance of A. You can see, children, there are 4A in the reactant side and 3C. So the rate of disappearance of A is 4 times, whereas the rate of appearance of C is 3 times. So the rate of disappearance of A is 4 by 3 into 6 into 10 to the power of minus 2. So that is 8 into 10 to the power of minus 2 mole per second. So this is the right answer. Let us go to the next question. Assertion A says that in a zero order reaction, if the concentration of reactant is doubled, then half-life period is also doubled. Yes, of course, assertion is right, because in T half we can see the formula. T half for zero order is directly proportional to the concentration of the reactant. So reason says half-life of zero order reaction is directly proportional to the concentration of the reactant. So both A and R are correct, and R is the correct explanation for A. We will go to the next question from electrochemistry chapter. So Nernst equation numerical is there. So EMF of this cell. So this is the EMF of the cell has been given. We will convert this into reaction. So nickel converts to nickel ion, and gold ion converts to gold. So we will write the reaction. 3Ni plus 2Au 3 plus gives rise to 3Ni2 plus Au. Nickel oxidation state is plus 2 and gold oxidation state is plus 3. To balance, we have taken 3Ni and 2Au 3 plus. Number of electrons will be 6. So in this case, first we will find out the standard electrode potential. Standard electrode potential is equal to electrode potential of cathode minus electrode potential of anode. So at cathode cation will migrate and undergo reduction. So here at cathode we can find cathode electrode potential is 1.5. That is gold ions will migrate towards cathode and gains electron to convert into gold. That's electrode potential is 1.5 minus, and electrode potential of anode anion will migrate towards anode. So at anode there is oxidation, so oxidation occurs here for nickel, it is losing electron. So for nickel the electrode potential is minus 0.25. When you calculate, you will get electrode potential of 1.75 volts. So let us go to the Nernst formula. Electrode potential of the cell is equal to standard electrode potential 1.75 minus 0.0591 divided by n. N is number of electron, that is 6, log of concentration of the product is Ni2 plus, its concentration is 1 raised to power 3, and reactant is gold Au3 plus, its concentration is 2 Au plus 1 to the power of 2. So here we will get 0. Log 1 is 0, we will get here log 1, and log 1 value is 0, 0 into this value is 0 only, so 1.75 volt is the right answer. So children, after substitution for log value, when you calculate, you will get log 1, and log 1 value is 0. 0 multiplied by this value is 0. 0 minus 1.75 is 1.75 volts only, so answer is 1.75 volts. Next question is very easy, related to chemical bonding. Which of the following statement is correct if intermolecular force of the liquid ABC is in this order? So as you can see, the intermolecular force in C is very high than A and B. So we need to find out the correct statement. The correct statement is B evaporates less readily than C. B evaporates less readily than C. Next question from solution chapter from Henry's law. So according to Henry's law constant value is given, KH is given. Henry's law constant KH value is given, that is 1 into 10 to the power of 5. For the solubility of a gas in water, the mole fraction of nitrogen is given. The mole fraction of nitrogen is 0.8. Then the number of moles of nitrogen of air dissolved in 10 moles of water at 298 Kelvin and 5 atmosphere. So first of all, we know Henry's law relation. Partial pressure of the gas is equal to Henry's law constant into X. So let us find out according to Dalton's law of partial pressure. Partial pressure of nitrogen gas is equal to its mole fraction X and total pressure. So mole fraction of nitrogen is 0.8 given. Mole fraction X means mole fraction. Mole fraction of nitrogen is 0.8 and total pressure of the air is 5. When you multiply, you will get partial pressure of nitrogen is 4. Now this partial pressure we will substitute in this Henry's law formula, where partial pressure value is 4, KH value is 10 to the power of 5, and we will find out the mole fraction of nitrogen. So mole fraction of nitrogen, when you calculate, you will get 4 into 10 to the power of minus 5. So when you calculate, you will get mole fraction of nitrogen into 4 into 10 to the power of 5. But remember children, that is not the answer. We need to find out the number of moles of nitrogen of air dissolved in 10 moles of water. For that, you can find out the number of moles is equal to mole fraction of nitrogen divided by total number of moles of water. As nitrogen mole fraction is very less, number of moles is very less, that we can neglect in the denominator. So number of moles of water is 10, mole fraction of nitrogen is 4 into 10 to the power of minus 5. When you calculate, you will get 4 into 10 to the power of minus 4. That is option A is the right answer for this question. Next is very easy. Raoult's law formula is option A. That is a very easy question. Let us move to the next question from coordination compound. Which of the following, which is incorrect for primary and secondary valency? So you can see in chromium, for this coordination compound, primary valency is 3 and secondary valency is 6. This is the correct statement. For second option, potassium, primary valency is 2 and secondary valency is 4. That is also right. Third one, platinum, primary valency is 2 and secondary valency is 4. That is also right. Whereas in the fourth option, copper primary valency is 4 is wrong. Secondary valency is 4 but primary valency is wrong. So option 4 is the incorrect among the following. One more is which is correct. So remember children, we need to find out the number of chelating rings. Chelating rings are formed by polydentate ligand, And when polydentate ligand combines with central metal ion, it should form 5 or 6 carbon 6 membered ring. 5 to 6 membered ring has to be formed. So among the ligands, EDTA is polydentate, but it cannot form chelating ring with central metal atom. Whereas DMG means dimethyl glycoxime. Dimethyl glycoxime is a bidentate ligand. After reacting with nickel, it can form 4 chelating rings with central metal. That's why option 2 is the correct one in this case. Next question belongs to D and F block elements. So the correct order of magnetic moment, spin only value among the species. So in the first case, iron is there with the strong ligand Cn 4 minus. So if you calculate the oxidation number of iron is Fe2 plus. So when you calculate, you will get iron Fe2 plus will be 3d6 configuration. So in 3d6 configuration, you cannot find any unpaired electron, no unpaired electron, because cyanide is a strong ligand, it leads to pairing. So definitely FeCN6 4 minus will be having 0 magnetic moment. Second, we have COCl4 2 minus. In this, cobalt is oxidation state is CO2 plus. It is in a 3d7 electronic configuration, and chlorine is a weak ligand. So in that case, you can find 3 unpaired electrons. In cobalt, you can find 3 unpaired electrons. Whereas in MnCl4 2 minus, here again chlorine is a weak ligand. Manganese will be in Mn2 plus oxidation state. It will be having 3d5 electronic configuration. So you can find 5 electrons. So manganese will be having higher magnetic moment. It is having 5 unpaired electron. Then cobalt, it is having 3 unpaired electron. Then iron, it is having 0 unpaired electron. So option D is the right answer for this question. Let us move to the next question. From coordination compound, which of the following is spin-free complex, means high spin complex. So wherever we find weak ligand, there we can find more number of unpaired electron. So that can be having high spin complex or spin-free complex. So among them, fluoride COF6 3 minus. If you see the electronic configuration, cobalt will be in +3 oxidation state. It will be having 4 unpaired electron. That way it will be having spin. It is a spin-free complex. Next one is an easy question. The melting point of zinc is lower because it is having completely filled d orbital. Another question from D and F block, potassium dichromate on reacting with peroxide in the presence of acid, it gives blue colored compound. So potassium dichromate on reacting with hydrogen peroxide in the presence of acid, it will form CrO5. In CrO5, you can find around chromium, peroxide oxygen also. So when you calculate the oxidation number of chromium, so you can see the oxygen in peroxide state also and normal oxygen also. So you'll get +6 oxidation state of the product CrO5. Next question, which does not have 6 membered ring, definitely diborane. You know the structure of diborane. Diborane does not have any ring. So the next question, 2-methyl cyclohexene on reacting with Bayer's reagent, it will form cis-1,2 diol. You will get diol, cis-1,2 diol. On treating with MnO2, it undergo oxidation to produce one keto group as well as alcoholic group. So option 1 is the right answer for this question. Next reaction also very easy. When phenol reacts with benzene diazonium chloride, you will get this compound para-hydroxyazobenzene which gives orange color dye. Let us move to the next question. In the next question, statement 1, primary amines having higher boiling point than secondary amine, isomeric secondary amine, definitely because primary amine having more hydrogen bonds. Statement 2, primary amines having more hydrogen bonding. Both the statements are correct here. Next question, when acetone reacts with Grignard reagent followed by hydrolysis, it gives tertiary alcohol. It will get tertiary alcohol. When acetone reacts with Grignard reagent, it will get tertiary alcohol. In another question, 85th question, this compound on reacting with alcoholic KOH, it undergo dehydrohalogenation to form KBr and water. You will get this product with having double bond and alcoholic group, cyclohexenol. So this on tautomerization, shifting of double bond and oxygen, you will get keto group, cyclohexanone will be get. So cyclohexanone is the right answer for this question. Let us move to the next question. So which of the following is a free radical substitution? So where you can find free radical substitution? Usually children, wherever you can find alkyl substituted aromatic compound, they undergo halogenation in the presence of UV light to form free radical substitution. If you want to see free radical substitution, you need to find out aromatic compounds having alkyl groups. Wherever you are finding alkyl groups, they undergo substitution easily in the presence of any halogen and UV light. So option 3 is the right answer for this question for free radical substitution. In the Williamson synthesis of ether given by this general reaction, among the option which will follow the sequence. So we know Williamson's ether synthesis follows SN2 mechanism, and in SN2 mechanism, primary alkyl halides are more reactive, or methyl halides are more reactive. So then option 1 is the right answer, because Williamson's ether synthesis follows SN2 mechanism. We have next question, cyclohexanol on treating with sulfuric acid, it undergo dehydration to produce cyclohexene. A is cyclohexene. So this cyclohexene, when you treat with potassium permanganate in cold condition, you will get 1, 2 diol. But here heating is given. When you heat in the presence of potassium permanganate, cyclohexene gives a dicarboxylic acid, which is called as adipic acid or hexane dioic acid. Let us go to the next question. Dehydrobromination. Dehydrobromination is one of the elimination reaction. It is can be found more in tertiary alkyl halide, then in secondary, then in primary. So option 2 is the right answer, because E2 elimination reaction can be found more in tertiary alkyl halide. Among them, the first one is tertiary alkyl halide, and the third one is primary one. Last question, which will give white precipitate with AgNO3. To form white precipitate, it should be forming AgCl. So wherever we can find the chlorine attached to sp3 hybridized carbon atom, means single bonded carbon atom, that is in option 1 and option 3. So there we can get free chloride ion to react with silver to form white precipitate of AgCl. So both 1 and 3 is the right answer for this question. I hope this is very helpful for you children. Thank you.